Hello and welcome to Experiment 5's pre-practical lecture. So in Experiment 5, essentially what we're going to be looking at is the specific viscosity of polystyrene in solution or polystyrene dissolved in toluene, so polystyrene solutions. And we're interested in discovering its what we call specific viscosity. Now, of course, viscosity is an inherent term, something that you know about, or if you've ever sprayed some honey or had to walk through a swimming pool or whatever, different liquids have different flow rates, different variable densities, in other words, different degrees of difficulty to move and different ways of flow and different ease of flow rates, essentially. And that's, of course, its viscosity, right? And that links towards viscosity of a liquid, of course, then is a function of its molecular size, the shape, and the intermolecular attractions of the molecules in that liquid, right? So that's a very short introduction to what viscosity is. I mean, everybody knows relatively what viscosity inherently is. And there are two methods employed in experimental experimental methods employed to study viscosity. The first is absolute methods, one where you essentially have some sort of force applied to an object and you study the object moving through a liquid under that constant force, and you see whether or not you look at the rate at which this object flows through that liquid. So for example, you would have a ball connected to a string and you would pull it up through a vial of oil or something like that with a constant force, and you would measure what is the rate at different forces, and then you would determine what the viscosity is of the liquid. However, in this experiment we will be using a concept called relative methods, where we compare the viscosity of two liquids. In other words, we use a standard or a reference liquid, which is toluene, and then we compare that to dissolving polystyrene in toluene, and looking at what is the effect on the flow or the viscosity in essence. In other words, the flow rate will change once we add polystyrene to toluene, and then what is the effect of that polystyrene in the toluene on the viscosity and hence the flow rate or the maneuverability of the liquid, if you want to put it in layman's terms, compared to just pure toluene. So in other words, a standard, right? Then the method or the specific apparatus to use for this is something called an Oswald Viscometer, and it is, of course, a relative method. And essentially what it does is we have a fixed volume of liquid in a specific area, and we time how long under the force of gravity. I know now there's still a force, remember, so it falls down under the force of gravity, but there's not an object moving through it. That's why that's not what we're studying, but anyway. And we're looking at how long it takes for the liquid to fall between 2 points. And we measure that then, in other words, we measure how long that rate as a function of the viscosity of the liquid. So that's what we get at the end of the day. Right, so now we look at the rate of the movement of the liquid, and that is a function of what the concentration is of the polystyrene in the toluene, and that gives us the idea of how the viscosity depends of polystyrene is. So because we have a standard, so we know what the time 0 is. In other words, what is the standard time it takes to fall down between 2 points in this viscometer. And then, of course, by adding polystyrene, you might get a thicker solution. So in other words, thicker solution will take longer to fall down between the 2 points. And as you decrease the concentration, you will get back to the toluene time it takes for the liquid to fall between the X and the Y points. And that is how you measure the viscosity, how the viscosity changes between the different concentrations. Right. And of course, you take a time average between triplicate measurements of these. These are all explained well in the experimental video. If this doesn't make too much sense, just go watch the experimental video. Right. Just a few notes on the results. What I would like you to have is you need to have your specific viscosity over concentration as well as your concentration all summarized within one table of data, please. And also you need to show your calculations for these values that you have. So in other words, have an example calculation. So you just need to show at least one example calculation. I need to show for each one, but I mean one example calculation, and then you list them in the table. You might also want to use your judgment to ignore some of these values, or do some sort of a t-test, some outlier test at a 95% confidence level to see whether or not you can ignore some of these values, because there are some difficulties in this practical regarding viscosity. Viscosity is not the easiest concept. You will notice I've, let's say, I've left out some parts of the theory on purpose, mostly because you don't do it in your theory course, and there's no use for me to delve in too deeply in it. You can read the practical manual on it. There's a very short thing on the theory, but viscosity is actually kind of a very difficult concept, and it's very difficult to measure experimentally, and most of it's based on assumptions, and there's actually no set theory for viscosity. So that's also why this experiment is very easy, because we can't go into too much depth because it gets very sticky, pardon the pun, it gets very sticky the higher the viscosity goes. Anyway, right. Anyway, so you need to do that. Then just a note, remember styrene is the monomer and polystyrene is the polymer, right? So if you're going to Google the molar mass of polystyrene, then it's going to give you the molar mass of one styrene monomer. So that is why your answer is going to differ from whatever you obtain in literature. The polystyrene that we have is going to differ from something in literature. So it's not really directly comparable to literature unless you bought it from exactly the same source, the same bottle, the same manufacturer, whatever. Then you're not going to link up the same number of monomers, you understand? So there is a little bit of, you can't really compare your value. So whatever value you get, don't stress if it's not comparable to something that you find on the on your research that you do on Reaxys, or even if you just Google, it's not going to be comparable. So whatever you get is what you get, right? And then finally, yeah, just as always, good luck. It's always, well, good to wish people some good luck. That is essentially it. Enjoy the experimental video. And this experiment, you'll see, is quite straightforward. It's just a lot of repetition. It's really not that difficult. All right, see you in the lab.